Hello, beautiful people, and welcome. In this video, we are starting our quadratic unit for graphing. As always, if I make a mistake, I am human. Please let me know where the mistake occurs so that way we all can learn from it. So what is a quadratic function? The quadratic function has an equation of f of x or y equal to x squared. Now, this is the most basic form of a quadratic equation, and there is also a secret bubble or a secret parentheses or a secret grouping with x. Now, you won't see this in yellow, right? You won't see this parentheses. However, x is grouped, and then you have the squared on the outside. Now, how does it look? The basic form, which is called the parent function, so this here is called the parent function. The parent function looks like a U or like we sometimes like to call it a smiley face, right? It looks like a happy U. Make sure that you have arrows on both sides. It also means that we have reference points. These reference points are points that if we were to make a t-chart, here's your x, here's your y, on this parent function, on this very basic quadratic equation, if I was to input 1, my input of 1, my output would also be 1. If I was to input 0, my output would also be 0. If I was to input 1, my output is also, negative 1, my output is also 1. If I was to input 2, my output would be 4. And if I was to input negative 2, my output would be 4. So notice that when we plug in our x values into the original equation, they give us an output that is similar for the negative x and the positive y. For example, if we take a look at the input of 1 and negative 1, our outputs are the same. If we look at 2 and negative 2, our outputs are the same. So this is called a reflection across the axis of symmetry. So here is the axis of symmetry. So if I have one jump from the axis of symmetry to the right and one jump to the axis of symmetry to the left, I'm also going to have two jumps from the axis of symmetry to the right. I'm going to have two jumps from the axis of symmetry to the left. This will come into play a little bit later when we are writing the equation or graphing the equation, but right now we're just trying to figure out how does it look. Now, where do we plug this in? We plug this into our equation, and in this case, we plugged it into our parent function to get those points. Let's go ahead and do some labeling. Shift this up a little bit. So as you saw, the line that is flipped. So if I was to take this quadratic and I was to fold it in half, this would be our axis of symmetry. So this line is our axis of symmetry. Notice that you have, in this example, two things on the x-axis. This is your x-axis. That means your 2 points here are your x-intercepts. Notice you have 1 point on the y-axis. It's a little bit difficult to see which one's the y-axis versus the line of symmetry. So I'm going to highlight, this is your y, this is your x-axis. And then you have your line of symmetry or your axis of symmetry, that is, which I'm going to highlight in yellow. So because we have something on the y-axis, this is going to be called the y-intercept. And notice that it has a minimum point, meaning it can't go below it. This minimum point, this point where it kind of bends, that specific bend is called the vertex. It's almost like the tip of the quadratic function. Now, if we have something that is added to our parent function. So our parent function is x squared. Now remember, let's write this out. F of x is equal to x squared. Remember, there's a secret bubble that groups x. And what we're talking about is we're talking about what if you have x squared plus a number. And sometimes you'll see k used to represent a number being added or subtracted. So if you have a number that is added, what happens is you're going to shift up that amount. So for example, we had a plus 2 here. That means my original parent function, I'm just going to quickly sketch the original parent function. This is the original that I just quickly sketched out. So our parent function, we picked it up and we went 1, 2, and dropped it. So we shifted it up 2 jumps. Now that is when you have something added. So what happens when we subtract a number to our parent function of x squared? So again, here's our parent function, f of x is equal to x squared. Again, x is in a secret bubble. So if we subtract, if we have f of x is equal to x squared minus k, so what happens, again, this is in a secret grouping, minus k is kind of like the opposite of what we just did. Now we're going to shift down k amount. So for example, we had a minus 2 here. Let me quickly sketch out the parent function. Must not forget the arrows. So here's your parent function. So if I was to pick this blue line or blue curve up and then drop it 1, 2 things down, I have now shifted down the parent function 2 spots. So what is the difference between adding and subtracting? When you add, you shift up. When you subtract, you shift down. Now this is called a vertical translation, meaning it changed up and down a vertical line shift change. All right, so what if we have an a value? So what if our parent function of x squared has something like an a value being multiplied by our x squared? So it all depends on the size of a and what you see. We want the absolute value of a right here. So a needs to be absolute value. We need it to be between 0 and 1. Now what we're thinking is like a fraction. If it is a fraction less than 1, then it's going to get a vertical compression. So if the absolute value of a, and this one is not x, should be a. We want to change that out. So if the absolute value of a is between 0 and 1, this will give you a vertical compression by a factor of a. And again, it's the absolute value of a. So what does that mean? So here's an example of the parent function. So this is not 1/2 times x squared. This is just the parent function x squared. So what do we need to do in order to graph this? Well, let's go ahead and just plug and chug our regular numbers using a t-chart. I'm going to do a thinking bubble here and see what the difference is. So here's our x values, here's our y. So if I plug in 1 here, so I have 1/2 times 1 squared, then I'm going to plug in 0 squared, and then I'm going to plug in 1/2 times -1 squared. So if my input was 1, my output here is 1/2 positive. If my input was 0, my output is 0. And if my input was -1, my output was a positive 1/2. So notice if I was to graph this is going to be a little bit difficult. I may need to use larger numbers. So if my input was 1, I have an output of 1/2, which is here. input of -1, output of 1/2, and here's 0. Let's use two more numbers. For example, let's use something larger than 2. Let's use something like 4, and I'm going to do it here, extend my thinking bubble. So if I have 1/2, and I'm going to use 4 squared, so my input is 4, and I'm going to use an input of -4 just to get the same thing. So I have 1/2 times 4 squared is 4 times 4, which is 16. 16 divided by 2 is 8. 4 negative times 4 negative, that is 16 positive, divided by 2, that is also 8. So when my input is 4, my output is 8. When my input is -4, my output is 8. Give us a little bit of larger numbers. So when we have input of 4, my output is 8. And input of -4, my output is 8. So let's go ahead and connect all the blue lines here. There it is. So what happens when your a value is between 0 and 1, if it's a fraction? What we say is we have a vertical compression by a factor of a, meaning it gets squished. Imagine if there was a big old foot here. Here's a foot. And that foot is doesn't really look like a foot, looks like a press. It's okay. Imagine someone squeezing it from the top. That's what happens when you have an absolute value of a that's a fraction smaller than 1. What about if your a value is not a fraction that is smaller than 1? What if it is bigger than 1? And again, we're talking about the absolute value of a. So let's think about our parent function here, which is x squared. And let's say, what if we have an a value that is greater than 1? And again, we're talking about the absolute value. Oops, we want greater than, not less than. Greater than 1. So if it is greater than 1, you're going to say you have a vertical expansion or a stretch by a factor of whatever a is. So here's an example of 2 being multiplied to your x squared. That means you have a vertical stretch by a factor of 2. That means that all of your vertical, your y values, are going to end up being doubled. So here's your x, here's your y. So let's say if I input 1, so 2 times 1 squared, then I have 2 times 0 squared, and I have 2 times -1 squared. This one will give me 2 times 1, which is 2. This one will give me 0. This one is 2 times 1 is 2. So when my input is 1, my output is 2. When my input is 0, my output is 0. And when my input is -1, my output is 2. So if I have, let me switch colors so you guys can see a little bit better. So if my input is 1, my output is 2. And if my input is -1, my output is 2. And I have 0, 0 still left over. So you're going to end up with something that's much more narrow. It's like someone taking this with their hand and pulling it upward. So you're having something more narrow that's skinnier because you are stretching it out. Imagine slime. If you pick up slime and you stretch slime, it's going to get skinnier. It's going to get closer together. So to recap, if you have a fraction between 0 and 1 for your a value, again, if we're not looking at the negative symbol, we're only taking the absolute value. That means you have a vertical compression. That means it's someone stepping on it, squeezing it from the top. If you have an a number that is greater than 1, then that means you have a vertical stretch. That means you are pulling it and it is becoming taller, skinnier. So what happens if we do have a negative in the front? So again, let's take a look at our parent function. F of x is equal to x squared. And if we have a value that is negative, and that's being multiplied by x squared. So when you see this negative, that means you have a reflection across the x-axis, meaning it gets flipped from here to here. Now your points are kind of almost going to be exactly the same. It just means you get flipped. For example, if I have input of 1 and -1 here, and my output was positive, so now I'm going to the negative section. If my input was -2, my output was 4, now my output is -4. If my input was 2 and my output was 4, now my output is -4. So we get flipped over across the x-axis. So if you see a negative a, there's a reflection across the x-axis, which means your graph will look like an upside down, like a frowny face, like an upside down U. You will have your vertex here, but it will be upside down anytime you have an A in the front of your equation. All right, beautiful people, that is it. Thank you so much for watching, and I will see you in the next video. Bye.